All right. Hello, everyone. It's Nono here, and this is the Nono.ma livestream. This is livestream 85. We started on the last livestream the third season. In this livestream, in case you're new, we do things that have to do with creative coding and machine intelligence. That is artificial intelligence and machine learning. But we also do many things that have to do with workflow automation, the Getting Simple podcast, which is a podcast about simple living, creativity, technology, and culture. And I also share a lot of the projects that I'm working on and share not only what I'm doing, but how I'm doing. I'm really interested in the process behind those activities or crafts that I try to do. I will say today, keep an eye. So we have a different setup than we've been having some other times. I have a stream deck here that I've been commenting on in many of the past live streams. I can control where I am on the screen, or I can also go hidden. And I also have a different camera that I've been using sometimes before. So if I just disappear and my image shows black, please let me know. I'll also ask for anyone who's watching live today, say hello on the chat, go and just type where you're connecting from or what your name is or how you found us. And make sure to also let me know if you can hear me okay and if you can see me okay. All right, so I think we can get started. As I said before, this is the Nonodoma live stream. I should have put this title slide before, but I haven't been live streaming lately, so it's I'm also using this setup with the Stream Deck, and I will invite you to like this video and also to subscribe and click on the bell to get notified when I go live next or when I upload new videos. And like the video if you're enjoying this content or if you would like to see more content from me. You can also join the community at None of the Maslas Discord or going to that QR code up there. And you can go to any previous live stream really if you go to None of the Maslas live slash and then the number of that live stream. So for example, for live 84, you have the URL right here. And you can see the intro to season 3. All right. Quick announcement I want to do today is that we've released in September a long-form conversation with Leire Asensio Villoria and David Ma. They're currently living in Melbourne, teaching there and also practicing architecture, landscape, and urban design. In this interview, we talked about their book, Systems Upgrade. We talked a lot about what it means to reverse engineer designs, try to dissect the rules and the guidelines that others try to embed on their designs and how that maps to drawings. Also talk about the long tail of niches, Irving Hauer, what associative models are. And a part that I was really interested in was book writing and publishing, how they went from ideas or essays that they have written before, maybe paper publications, to a crafted book that you could read on paper, right? I read the book before our interview, and there's a lot more. So you have a QR code down there as well, or you can just go to gettingsimple.com and take a look. All right, so as always, you can submit a question about this episode or any previous episodes at gettingsimple.com/ask. We have some episodes down the line that are gonna talk about questions or like guest conversations as well on how I do things or certain questions that people had. And we need to revisit these goals this season, the goals of like creating a machine learning course, collaborative AI sketching platform. I realized that it's really hard compared to what I initially thought we could do with the amount of time that we are dedicating to this, because we don't get to do as much development as I would have liked. Maybe it is just a matter of me scheduling more hours on Thursdays or some other day. We've talked about this before on the live stream, but we'll get to that. We'll see when that can happen. We're back to uploading videos to YouTube, so you can see those dropping on the channel mainly on Mondays and on the websites. Yeah, so we'll continue and see how everything evolves. All right. And today, one thing that I'm doing here with the Stream Deck is that I'm creating timestamps for this video as we record, so you can probably take a look at this video if you're watching after this has been. All right, and this is what I meant before. So we're probably overheating the camera, so there was something going on in there. So I'm not sure if that's gonna keep happening. At least I have the recording to read what happened in there later after we finish with the live stream. It's also there, so you can scroll back and let me know if you want to read it. So this might happen a few more times during today's live stream. I will have to figure it out and fix it offline, but you know, I can restart the camera and everything seems like it is going well. So it might just be that the camera is overheating. All right, so today we don't really have any agenda. I definitely want to get back at creating content that has to do with machine learning and surveying what's out there. We've covered DALL-E and some other networks on this stream before, and yeah, so let's get started. Let's see what we can get to today. I didn't really prepare any more slides. We had this intelligence sketching playlist before where we've done, okay, let's see what that, cool, okay, allow it to cool. All right, so what I'm gonna try to do is I'm going to stop charging the camera and allow it to cool down a bit. I've been trying the camera before for a bit and I think it's a bit warm. So yeah, so maybe we just need to let it cool down a bit. All right, so you might not see me here on video a bit, but I'm gonna continue and keep going. We had some covers here and yeah, so let's get started. Let's see what we can do today, what we can get done today and keep going. I would also, you know, remind myself here that I've been looking at decision trees. So I've been looking at decision trees, neural networks, and other things offline. So that is something that we might see on the stream. And actually what I'm gonna do here is I'm gonna open a window and I'm gonna see if there is like any TensorFlow decision tree tutorial, because TensorFlow, they actually have a bunch of tutorials online and that might be, you know, it might be good to see some of those. All right, so great. So decision forests are a large family of machine learning algorithms for supervised classification, regression, and ranking. As the name suggests, DFs use decision trees as a building block. Today, the two most popular decision forest training algorithms are random forests and gradient boosted decision trees. Both are ensemble techniques that use multiple decision trees but differ on how they do it. TensorFlow Decision Forests TFDF is a library for the training, evaluation, interpretation, and inference of decision forest models. So this is something that we could take a look at. I'm not sure we're gonna have time today because I don't have too much time today, but this is something that I really want to take a look at because it really helps understand machine learning concepts or of other algorithms. And what I like about decision trees is that they're actually easy to explain, right? Like you can visually see these algorithms, and I believe these are the type of algorithms that are called white box as opposed to a black box. They are interpretable and you can see why they're making the decisions that they're making. Let me see. All right, so we don't have too many graphical inputs here. So if I look for decision trees, okay, so these are the diagrams from the book that I'm looking at that I want to try to generate, right? So these are decision trees that are actually, so this is the book that I'm reading, Hands-on Machine Learning with Scikit-learn and TensorFlow. And these are actually the type of decision trees that I want to try to do. So these ones I think you do with scikit-learn. And yeah, so let's see, let's keep taking a look here at the TensorFlow tutorial. Okay, I'm gonna actually try to switch on the webcam or the camera and see if this works. Something super annoying that happens with this camera, at least I haven't figured out yet, is that because I'm using digital zoom, it resets the zoom that I'm applying to it every time I reset the camera, which shouldn't happen. I mean, I shouldn't have to reset the camera. Okay, I'm back here. Yeah. So I'll try to see, I mean, how we can get rid of this problem. At the moment, at least, we are not, so we're not charging the camera, so it might not happen again. All right, so let's see how long this is. So introduction, this tutorial you'll train a binary classification random forest on a dataset containing numerical category and missing features, evaluate the model on a test dataset, prepare the model for TensorFlow solving, examine how the overall structure of the model and the importance of each feature, retrain the model with a different learning algorithm, use a different set of input features, change the hyperparameters of the model, pre-process the features, train a model for regression, and train a model for ranking. Installing TensorFlow decision forests. All right, so this is actually a framework, a complete framework. I'm not sure if there is. Drag an image here, search any image with Google Lens. All right, so this I hadn't seen before, this menu here from Google Lens. I know Google Lens works this way, but let's actually try it. So by drag and dropping that image, I can actually select this part and look for similar images. So this is Google Lens, right? I'm not sure. So if I go to lens.google.com, go to Google Lens. It's they show me like an iPhone app, lens.google. But if I just go to images, decision trees, that menu showed here. I'm not sure if it's, oh, okay. So we just need to click on this symbol. So I just click here and then we see this panel pop up and we just have to drag and drop an image. And then we get this interface where I can clamp to a subset of the image. And then Google Lens is going to look for similar images. It's actually found the same image here or like a similar diagram. Let's try to change it a bit. All right. That's cool. Let's see what other charts we get. Okay, well, yeah, enough for that. So this was Google Lens. All right, let's keep going with what we were trying to look at. Okay, and in here, just as a way of showing the progress, like I can say, for example, here I put a marker for decision trees. Here I put a marker for Google Lens, and then here another one for decision trees. And I can put here one for introduction, right? So this is just me making the markers of this live stream even before it's finished, which is, I think it's pretty cool. All right, so I'll leave this on my other screen here. Okay, awesome. Okay, so let's actually just try to see if we can get this running. One thing that happens in my case is that I have I have an M1 Apple Silicon Mac, so I might not be able to get the latest TensorFlow version running here. That's like a more tedious process, but I'm sure that we can run this all in Colab either way. Let's actually go straight to Colab, so I don't, we don't get that problem, because otherwise I might find that I cannot run it. I cannot run this example. Okay. So build, train, and evaluate models with TensorFlow decision trees, introduction, license, blah, blah, blah. Yeah, so this is just there. All right, so I'm gonna close this table of contents and we're gonna get started with this part here. So pip install TensorFlow decision forests. One thing I'm gonna do runtime, I always try just to get here into runtime. So runtime, change runtime, and then we go into GPU, right? So we reserve GPU. If you are Google Colab Pro subscriptor, then you can get more access to better GPUs. All right, so we get that, and then we can hit connect here or just play. So if I hit connect, they allocate an instance for us. You can actually just hover here and it tells you what instance we're connecting to. And now it's initializing. We're going to have a Python 3 Google Computer Engine backend for free. And this is Google Collaboratory. So you can go at collab.research.google.com. There is actually AWS Studio, SageMaker Studio Lab, which is it's a similar functionality to what you get on Google Colab. I guess it's a response to Google Colab from Amazon, so people just stay inside of their ecosystem instead of going to Google's. And all right, and yeah, so we go. You see here, for example, that SageMaker Studio Lab is free machine learning environment, storage up to 15 gigs, blah, blah, blah. And you can probably access GPUs as well. Studio Lab offers either CPU or GPU sessions. You can choose to run notebooks with a 12-hour CPU session or a 4-hour GPU session. Yeah, so they just made their thing. And I can see Eren or Iren on the chat live, chatting live. So where are you connecting from and how do you find us? All right, and I'm going to continue here. So the first thing, I'm going to share this page here of decision trees or decision forests tutorial. And I'm going to, well, I mean, you can get to the to the notebook by simply clicking on Run in Google Colab. So I won't put that that link there. Okay, so we're here. We have an instance. We can see a bit more of it in here. So we have 12 gigs or 14 or 16 gigs of RAM. I don't know. It says 12.68 and around 80 gigs of disk. So I'm just going to click here. So this is not authored by Google. It's being loaded from GitHub, and it's actually authored by the community. We're just using a method to load a Colab notebook from Colab directly. I actually have a video on the topic, so let me try to see if I can link to that. Yeah, so how to open Colab notebooks from a bookmark. All right, and let's keep going. So we're gonna run it anyway. It's usually good practice to save a copy so you can edit, because if it's not your notebook, you're not gonna be able to do anything with it. So we can save a copy on Drive actually, and that will open a new Colab notebook. So what I'm gonna do, I'm just going to leave this instance. I'm gonna put here a note of decision forests live 85. All right, great. So going back here, I'm gonna do the same thing, runtime change to GPU, and we're gonna run this, and we're gonna kill the other session if this lets us. All right, and now we'll start running cells from here. So as I said, you can just click this play button and start executing the cell. So this is going to install the TensorFlow Decision Forest package. So we can probably look for that on PyP. And here's the package. I'm not sure we can see the dependencies in here. Is this GitHub? Yeah. Okay, so homepage. We're gonna like the project. TensorFlow Decision Forests is a library to train. This is what we read before. And where do you define the dependencies? So this is all the things that need to be installed, maybe, or to build. Basically, is to build the library. All right, so let's keep going. So we are resolving our dependencies here in Google Colab. And the first thing, I mean, I have to say, I usually don't like to just do tutorials going through a Google Colab notebook, but because I haven't prepared a lot for this one, I'm just going to try to see what they do to get a high level idea. And maybe in the future, we try to rewrite from scratch and come up with a few different things that we can do on our own, right? So Wurlitzer, which is also another PyP package, captures sea-level steady out pipes, is needed to display detailed training logs in Colabs when using variables 2 in the model constructor. All right, so we're going to install that as well. And here in our Python file, let's say, we're importing TensorFlow decision forests as TFDF, right? So we're namespacing or naming this TFDF, so it's easy to access to it later. We can do TFDF dot, and then we'll get autocomplete, right? So we play, we also get the system library, NumPy, pandas, TensorFlow, and math. And, there are things that we can do here. I think I have, so we can, once we import TensorFlow, we can get to this code block to print the TensorFlow version, the Python version, and also see what GPUs are available on this instance of Colab. So we verify what we have, right? So we can click on play as well as before. And okay, so we have TensorFlow 2.10, which was released fairly recently, Python 3.7.15, and we have a CPU and at least a GPU. So we have this Tesla T4. Okay, right. So this block I added. You don't really need it. I could say, can we hide this code? Whatever. All right. The hidden code cell limits the output height in Colab. Yeah, I don't know what that refers to. All right, so we're gonna keep going. The hidden code cell, title, blah, blah, blah. So I'm going to execute. So some of the model training logs can cover the full screen if not compressed to a smaller viewport. This magic allows setting a max height for a cell. So register line magic, set cell height size, IPy display, Google Colab parameter, string size. All right, so we'll see how this works later. This is some Colab wizardry. Check the version of TensorFlow decision forests, which we didn't check before, and we've seen that this matches what we've seen on PyPy. And so far, the only thing we've done is we've installed our dependencies, we've did some Colab magic there, saw what GPUs were available on Python and TensorFlow versions, and then saw the TensorFlow decision forests version. So now it's when everything starts, right? And we could actually port all of this to our own Python file and run it locally. I'm actually eager. So far what we've done, let me see if I can reproduce all of that in a Python environment. So if I go here, I do, let's put here, this is live 85, right? So let's go into 85. And with Conda, I'm gonna what was it? Create. We're gonna call it TFDF decision forests, and we're gonna do Python. So what version we have there? This is Python 3.7. So let's try to do 3.7, and that's it. Let's see if we can, we create these environments. Let me remove one equal sign. What's going on? Okay, I'm gonna cheat. I'm gonna go to my channel again. I'm gonna check for a video I have. Like I have the cheat sheet for that command for some reason I don't remember right now. Oh, I need to put a name. Okay, I forgot about that. So what we're gonna do is that, but wait one sec. Conda create Python. All right, Python 3.8, it like that. I don't know what happens with 3.7. Let me see if I do here Python 3.9. So this is creating our environment. And what we're going to do next is we're going to access that environment, and we're going to also try to install this library. And I don't know if we need this one, but we'll try. All right, so now we do conda activate tfdf for TensorFlow forest. So we're inside of our environment. So is it tfdf, right? So we have this environment, and that's the Python that we're using, and it's 3.8.13. So we just do, well, we verify that pip is what we want, and we just try to install that. This might not work because there are some dependencies that we have on the system, like TensorFlow, for example, that are not straight compatible with Apple Silicon. So let's see what happens here. All right, so we have TensorFlow macOS 2.10, and that, if this works, I would be surprised because I've had a lot of compatibility issues other times, and this seems like they figure it out properly. Let me actually take a quick look at TensorFlow macOS 2.10. All right, so this was released a bit before, and it seems like since 2.5 they just keep releasing, so that's really good news for us. All right, so this keeps building stuff. It also took some time before. Later we'll start installing this one. So let's keep it going. So this is actually like an M1 Mac, and it's also a good exercise to see if there's compatibility. All right, so we got up to here. So we had our version of the random forest, so the decision forest library. And now this tells us that we're going to train a random forest model. In this section, we train, evaluate, analyze, and export a binary classification random forest trained on the Palmer's penguins dataset. Palmer penguins. The Palmer penguins R package contains two datasets that we believe are a viable alternative to Anderson's iris dataset. Yeah, so that one is the one with like petal length and all of this flower images, right? Not sure. So we look here. Right, so there's like a lot of works that use this data set as a benchmark to classify images, or like actually flowers, by photos of those flowers on the with machine learning, right? Right, let's do something here live. I'm gonna go to Twitter, and I'm gonna go and tweet. I'm gonna say, what can we show here? There is actually a function here. This is a bit off topic. All right, let's take a quick I'm just gonna do something really quickly. All right, so there's like things that are starting to fail here while building, but I'm not gonna look at that right now. I'm gonna delete this. I'm gonna look at the Stream Deck. I'm gonna look at, there was a function here that is to take a screenshot of OBS. And I want to see how this works. So if I click, where does that save? So that saves to where all my OBS recordings are. Oh, wow. Okay. So this is really nice. So if I look here, or if I change to camera. All right, so let's take a look at those images. So those images are PNGs. Oh, okay. So I can create thumbnails this way really easily. And the resolution is, what is the resolution? All right, so let me take a look at OBS. So this thing is making a lot of sound. So there is, so we take a look here at OBS's panel. This is actually, let me just comment on this really briefly. So this is OBS's stats panel, and this is completely changed in topics that has nothing to do with what we're taking a look at regarding machine learning. This is telling us how many frames we've lost due to rendering lag and how many due to the network being slow and how many due to encoding lag. So it seems like everything's working pretty well. We're streaming at 30 frames per second. We're not using almost any CPU. And there's like a lot of disk space available for us to continue recording. So far, the total data output, we're at 2 gigs, I think. I think that's what this is showing. I'm not sure if I have the setup properly there. And I don't know if this is due to the session or due to the current recording. So if I look at the current recording, yeah, so we're at 2.38 gigs, which is, I mean, matches this. So yeah, I mean, it seems I could reset here just to make sure that we can track. But well, I mean, we have 7 missed frames, so I'm gonna close this now. And yeah, so we have the new screenshot button there in the Stream Deck. Okay, so we're back here. Encounter error while trying to install the gRPCO. This is an issue with the package mentioned above, not pip, see above for output failure. All right, so if we look, there's something that needed to be built that didn't really work. There's like a bunch of stuff here. And I guess that if I do then Python here and try to import TensorFlow, what is that? TensorFlow decision forests as tfdf. I don't think that's going to be found. And import TensorFlow as tf, that's not found. All right, so that failed. Okay, so let's quickly take a look at how to install TensorFlow on a macOS on M1 or M2 chips. So we just have to do pip install TensorFlow. This is supported for a long time now, and we're gonna get this error. So the only thing we need to do is say pip install TensorFlow macOS, and that will automatically start installing the packages that are required. And okay, so here I can see that gRPCIO is going to be try to be built, and that might fail again because that's what just failed on us a second ago. All right, and we're getting the camera again without power or something because it's heating up a bit too much. Let me actually see. Maybe I can do something. And all right, so a bit of interlude here. Right, so we're gonna seek out to create an OBS scene, and I'm taking a look at some of the links and markers that we put in here. All right, so this might not build. I'm gonna let it sit for a second, and while we do that, I'm gonna take a look here in OBS. We could actually have a slide for the break, but I'll do that offline. So what I'm gonna do is I'm just gonna open this break slide that I have here. Put this on full screen and go. And I'll be back in a few minutes. All right, so we're back. I'm going to try to set up the camera once again. All right, till it lasts. Great, so we got the same error when trying to install TensorFlow, and we're just gonna leave it there. All right, so that's what happens. So what I'm gonna do, I'm gonna deactivate this environment, and I'm gonna do gonta remove dfdf. I think you can put here all, and we say yes, and that will just get rid of our Python conda environment that we created to try to install TensorFlow locally here. So I'll have to take a look. So as you've seen, there's not super good compatibility yet, and I'll have to figure out why. Okay, so we've seen that. So the data set, we're back here. So this is training a random forest model. So we're going to take a look at how to use TensorFlow decision forests to train a random forest model. And we're going to be using the Palmer's Penguins dataset. The dataset was exported to a CSV file without pre-processing. Library, Palmer Penguins, write CSV, Penguins, file, Penguins, quote F, row them Fs. So this is how you could reproduce the generation of the dataset that we're going to use. Load the dataset and convert it in a TF dataset. So this dataset is a very small, 300 examples and stored as a CSV-like file. Therefore, you can use Panda to load it. Pandas is practical as you don't have to type in the name of the input features to load them. For larger datasets examples, using the TensorFlow dataset to read the files may be better suited. All right, so for large datasets, we'll use TensorFlow dataset, right? But for small datasets, you can use Pandas. Let's assemble the dataset into a CSV file, add the header, and load it. So we're gonna download that CSV file that they're put for us already on Data Palmer Penguins, and we're going to read that CSV with Pandas, and then we're gonna show it and display the first three examples. So we play here, we download, and then we display, right? Species, islands, blah, blah, blah. So this is actually being downloaded here, or where? wget. All right, let's look at where that's downloaded. So I'm gonna put here ls sample data. We're in content, and this has been downloaded to temp penguins. All right, so we can actually go to temp and penguins, right? So you see temp penguins, so we can double click that file and we can see it. So this is the file. We can actually go, so I've opened, but how can I? So Google Colab already previews this for me as Mac does. So for example, you could come here, download this file, and then we can preview this file here. So it's just a CSV, the header columns are there. And what I really wanted to see were the raw contents of that file, which we can see if we put here cat temp penguins CSV. Right, so these are the actual contents of that file. Is a CSV. All right, so we're gonna delete this so we understand the data. So we have the species, the island, the bill length in millimeters, the bill depth in millimeters, the flipper length in millimeters, the body mass, sex, and year. Let's take a look at penguin bill. What is it? Oh, so the bill is the beak. So this is the bill length, right? I think. Reach along the top part of a bird's bill. So the culmen is this, which is probably what they're calling the depth, right? Palmer Station penguins classification. All right, so here this explains the culmen length, the culmen depth. So they're calling it bill. So this is the length and the depth. and then they're also putting other data as the weight, and so the average body mass, and the island, the species, and whether they're like male or female, right? Their sex and the year. Okay, so let's take a few more so we see a bit more of this. All right, why is number 3, which is actually number 4, not a number? Cat, we're gonna do cat, none. Temp penguins.csv. All right, so I'm gonna go and, oh, okay, not a number. I don't know why. That might, sometimes those are there so your algorithm knows how to deal with nuns, right? With like not a number, or like things that are not really well formatted. But yeah, all right, so let's keep this at like 4 so we don't make this too tall. We now know what the data set is about, and we're gonna move on. So in this section is how to encode the categorical labels as integers. Name of the label column. Label equals species. So we're gonna try to figure out, I guess, the species according to the data that we have, right? So this is what we're trying to figure out, like what species a penguin is according to their bill length, their bill depth, the flipper length, right? Like their sort of wings, body mass, sex, and year. All right, so we say, okay, label is species of the label column. Classes, we're gonna get the different classes and we're gonna print them. And then we have the data set, data frame. We're gonna get the label, which is species. We're gonna get the value of that, and then we get that label mapped into classes.index. All right. Okay, so let's try to understand this. So we have Adelie, Gentoo, and Chinstrap, right? But we're gonna decode this a bit. So if we do dataset df, right, we have the entire dataset, right? And this is some magic there. Okay, I guess that's some magic from, is this magic from pandas? Yeah, probably, or Google Colab, I guess. All right, so if we look here, so if we put here, basically the value of label is species, right? So if we put a dataset data frame label, we're just calling dataset df species, and then we're getting the unique values, right? So we get dataset df label, and we're getting like a set of values, and we're just gonna do them, make them unique. So you have 0, 2, and 1, and then we'll do to list. So we just have 0, 1, and 2. What happens here is that we're getting those mapped to the indices, right? So index, so let's do here, these are going to be our classes, and we'll do classes.index. And then this is, I don't really know what this is. This is a list, Python. So this is Python list index, and that value index. All right, so we can get that index the index class and element start end. Okay. Let's actually tweet here. Trying to classify penguins to guess the species of penguins with decision forests. And I'm gonna put a link to this current video in case that somebody connects with us. And maybe we can use the thing that we learned before about. So this is called Palmer's penguins. Let's put here Palmer's penguins length Coleman. Let's try to look for the. All right, so I can actually open this. And if the camera is working, we can take a screenshot. All right, so sorry guys for this, but I think that might be good to see kind of like a post here in the raw data regarded as Coleman. All right, so maybe that's it, and we just put this here. All right, so we're gonna tweet that. Great. Okay, so we were looking at Python leaks index, and yeah, just trying to understand that function, right? So we go here. So if I do index Adelie, oh, Adelia, probably -1. Oh, it's not on the list. Adelie is not in list. Okay, yeah, so probably just 0. So our list, our classes are, okay, so if I do I don't know, like 3, 4, 5, and put here index of number 5, it's gonna be 2, right? All right, so it's just giving us that. So if we have a, so for example, dataset df species. Okay, so it's like 0, blah, 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 map, classes, index. Okay, I see. So they're just trying to I see. So what they're trying to do is simply replace the appearances of this with like 0, 2, so 1, 2, and 3, or 0, 1, and 2. That's what I think is going on. So let's run this again. Let's run this again. So we have the data set. We do this again, and then we print the dataset df. All right, so you see, okay, I guess like I didn't fully wait until we saw that, but what happened here is that we've mapped, instead of having species as being Adelie, Gentoo, and Chinstrap, we've mapped the class index. So now where it said Adelie is going to say 0, where it said Gentoo is going to say 1, and when it said Chinstrap, it's going to say 2. I guess it's fair if we do penguin search here and compare the 3 classes that we're looking at, just to know what problem we're working with. How do I center you? Okay, and then we have Chinstrap. All right, so these are the classes of penguins that we're trying to classify. And the left is Adelie, the middle one is Gentoo, and the one on the right is Chinstrap. I think they're fairly different. I believe this one, actually, even before I saw Australian, this is the one that I saw in New Zealand, I believe, because they were, yeah, I don't think they were this or this ones. Yeah, definitely not this ones. So yeah, they're pretty different. I guess like with image classification, we could get a really decent results as well. So yeah, this is our problem. These are the types of penguins that we're trying to classify here. All right, and we can keep going for a bit. We have next split the dataset into training and testing. So split the dataset here, splits random length dataset test ratio. All right. Finally, convert the pandas data frame into TensorFlow datasets. So we're just putting here the train and test, Keras. So this is TensorFlow, decision, forest, Keras, pandas data frame to TensorFlow dataset. So this is a really nice helper that comes from Keras, I guess. Converts a panda data frame into a TensorFlow dataset compatible with Keras. All right. Future warning. In future version of pandas, all arguments of data frame drop except for the argument labels will be read-only. Okay. Recall that PDF to TF dataset converts string labels to integers if necessary. So why string labels to integers if necessary? Why did we map that manually above? I don't understand. If you want to create, it seems redundant to have done this by hand, right? Encode the categorical labels as integer. This state is necessary if your classification labels represent as a string, since Keras expects integer classification labels. When using this method, this step can be skipped. Okay, so I hadn't read this before, but it seems fair that, you know, we did this because this is what you need to do in any type of training problem algorithm. But if you're using the PD data frame to TF dataset method, you actually don't need to do that because it does it for you. All right, train the model. Set cell height 300, specify the model. It's going to be random forest. Remember, verbose 2 gives us a lot of input, but also output. But because we have the Wurlitzer library, it's needed to display the detailed training logs in Collabs. All right, so let's go and train. Let's see how long that takes. So you're going to train the model. All right, use 2 threads for training. You see what this does, it seems like the thing that we had above with Wurlitzer is that it prevents Cola from making this cell too big. I think that's what I think I understood, because there's like a lot of text here. Features, island, build length. It's actually grab this data. All right. Cool. So we've trained the model here. I was gonna open the this file here just to see its contents. So if we, let me see if I can get this, maybe like this. All right. Okay, so it seems we have these features. This is all automatically done by TensorFlow decision forests by the Python package. It knows that island is going to be strings, and every other parameter except for sex is going to be float 64, right? And int 64 in the case of year. And sex will probably convert it as well as string into indices, right? And they turn into categorical variables, and everything else is numerical. So it's really nice actually that just by inputting a CSV file, we get all of that for free, because this could help you actually figure out for your data set what you need to do just by ingesting that file inside of the data frame and pandas and then into keras, and get that all for free. All right, so we have trained here, and there are a few remarks that we're going to read. No input features are specified. Therefore, all the columns will be used as input features except for the label. The features used by the model are shown in the training logs and in the model summary, which I just showed. Decision forests consume natively numerical categorical set features and missing values. Numerical features do not need to be normalized. Categorical string values do not need to be encoded in a dictionary. No training hyperparameters are specified. Therefore, the default hyperparameters will be used. Default hyperparameters provide reasonable results in most situations. Calling compile on the model before fit is optional. Compile can be used to provide extra evaluation metrics. Training algorithms do not need validation datasets. If a validation dataset is provided, it will only be used to show metrics. Tweak the verbose argument to random forest model to control the amount of displayed training logs. Set verbose 0 to hide most of the logs. Set verbose 2 to show all of the logs. A categorical set features composed of a set of categorical values, while a categorical is only one value. Okay, more details and examples are given later. All right, so now we're going to evaluate the model. So now we're going to evaluate the model. And as we're looking into a Google Colab notebook, I'm just going to continue executing and try to understand the code because this is the first time that I see this code. But bear in mind that in the future, we'll have better examples and we'll actually be coding. So we run model compile with metrics, accuracy, evaluation, model.evaluate in the test set, and we return a dictionary and then print it. For name value in evaluation items, we print. So we have here loss and accuracy, right? So our items here, so we go into evaluation items, we're actually outputting a dictionary with like string to the value, right? So we'll leave this here. So our accuracy is 98%. The test accuracy is close to the out of the bag accuracy shown in the training logs. See the model self-evaluation section below for more evaluation methods. Prepare this model for TensorFlow serving. Export the model to the save model format for later reuse. All right, so I'm not so, so worried about saving the model and actually, so serving the model in TensorFlow serve. What is the name? TensorFlow serving. I would like to actually make predictions with new data so we see the results, right? Plot the model. Plotting a decision tree. All right, so let's put here. Plotting a decision tree and following the first branches helps learning about decision forests. In some cases, plotting a model can even be used for debugging. Because of the difference in the way they are trained, some models are more interesting to plan than others. Because of the noise injected during training and the depth of the trees, plotting random forests is less informative than plotting a cart or the first tree of a gradient boosted tree. All right, so if we go here, we see that they were telling us that we are training a random forest model. So we go into here. Nevertheless, let's plot the first tree of our random forest model. All right, so here's what's happening. If the bit length is more than 41.5, we have a 30% probability that is of class 0, Adley. All right, yeah, you can see that actually if we go back to the chinstrap penguin, their beak is super short, right? So there is less probability that it's going to be one of them. The depth, if it's deep, number 1 had the deepest one. All right, great. So if we look at the, what was it? Adeli. Okay, so this is the deepest, it seems. All right, so long story short, this is the result of the training. Like the algorithm has created these trees that you can actually understand by these conditions, right? If it's greater than this, it's gonna continue going this way. If it's lower, it's gonna go in this way, and so on and so forth. And actually, what is really nice is that it tells you where the path that each of the classes or species are taking. So if you go down this path, you won't have any more than class 0. This one is more class 2, it's class 1, and this is mainly class 2. The root node on the left contains the first condition, number of examples and label distribution. Examples that evaluate true to val are branched to the green path. The other ones are branched to the red. And we're plotting the model. Okay, so TFDM model plot model in Colab. So they actually have a utility function to plot this here in Colab inside of the library. Examples that evaluate to true to build blah blah are branched to the green path. All right, so yeah, there is like a green path and a red path, and this keeps going, but just goes okay. All right, so I see there's like two extremes on each of them. The deeper the node, the more pure they become. The label distribution is biased toward a subset of classes. Over the mouse on top of it. I guess this is hover. Model structure and feature importance. Model structure and feature importance. The overall structure of the model is shown with .summary. So you will see, so let's run it first. Set cell height. Okay, so this is the magic, I think, that we put before. Okay, so we're gonna see the type, the learning algorithm used to train the model, random forest. Task, the problem solved, classification, input features, the input features of the model, different measures of the importance of variable importance, out-of-bag evaluation, the out-of-bag evaluation of the model. This is a cheap and efficient alternative to cross-validation, number of trees, nodes, and other metrics. All right. So we see here first the model, right? So we have a trainable parameter, which I guess is a class. So the task is the classification of the label. We have 7 features, no weights, variable importance. It seems like sex is the most, no, year is the mean depth. I guess like this means that build length is the most relevant. Yeah, I guess like variable importance, num as root. Okay, yeah, so this is what determines mainly the, I guess, the classes. So build length is the most determinant, then flipper, and this is probably going to be the order in the chart, right? Build length, build depth. Does this continue? Max depth, let's go to 5. Okay, so this continues. All right, yeah, so actually some of the things repeat, but build length, depth, then island, depth, length. All right, yeah, I'm not sure. I mean, not exactly. Yeah, so we get a lot of metrics here, and we could understand a lot more of the model. The information in summary are available programmatically using the inspector, feature, variable importances. All right. Great. So the content of the summary and the inspector depends on the learning algorithm and its hyperparameters. All right. So let's take a quick break. We're going to end really soon. Okay, so we're up to evaluating and seeing the importance of some of the features. I'm gonna leave it here today. We have to go now, but I think we've understood something. I was looking at the hands-on machine learning with Psyche and TensorFlow book. So I was looking edition 2. So this is more yeah, so this book actually, I was just reading about decision trees and stuff. I've shown this book repeatedly here on the live stream because it's the one I've been looking at the most. And we're gonna continue. So for me, this was one way in which I saw how easy it can be to train a decision forest algorithm. I just follow a tutorial. I mean, just use the Colab. I haven't really coded anything today, but I think we're gonna be able to use some of these things down the road. I look forward to like doing some more interesting stuff on the channel with the sketches dataset that we were building before. We're gonna take it back. So this was for those of you. So for those of you who have been following the past seasons, I'm now back. So I have like a live streaming setup again. I hope that this sounds good, that this looks good, and I'm gonna get rid of that problem with the camera. But yeah, let me know what you think. We're gonna prepare better contents for the future. I might bring some guests this season. I'm gonna try to see if I bring some guests and have like two-way conversations. We have also Riverside FM, which is a tool that I might use for. I don't like that in the live stream it actually has really low quality, so I'm not sure if I'll do live streams with that. But I like the fact that I can record every participant's audio and camera, and I can invite calling guests and things like this. So if you give listen to any of the Getting Simple episodes, let me know, or ask any questions, submit them at gettingsimple.com/ask. And yeah, season 3 is back here. I'm gonna try to stick to most Thursdays, or at least one live stream every week. Give it a like if you want to keep seeing me show up every Thursday. And of course, subscribe if you want to contribute to the work that I'm doing here with these videos and the live stream. If you're excited about machine learning, creative coding, and many of these things, and click on the bell so you get notified when I go live next. And I upload new videos. I actually was showing you this, but I was on main camera. So this is something that is happening to me with having the stream deck here by my side. So what I was saying is like it and subscribe if you want to get notified. And yeah, of course, join us on Discord at Nono.masa's Discord. You get the invite. And yeah, thanks a lot for watching, and I'll see you next time. Bye. Let's take a screenshot here. I usually extract these thumbnails from the video afterwards, but having the possibility to take a thumbnail directly from OBS with the, I mean, I didn't know you could do that, but now having that button here on the Stream Deck, it's super nice. I have to say, finally, OBS 28 was released, and the Stream Deck caught up with the drivers and the plugins, and now I have full control of my OBS session from the Stream Deck. So I can go to the right, I can go to the left. Well, I can disappear, I can go to the right, I can go to the left, or I can go full camera, right? So I have all these modes to move around without having to touch my mouse or the keyboard. And I can also go back to the first slide, for example, or go to the last one and move around keynote presentations this way. So now I see there's someone live at the moment. So let me see. Also, we have that the weird setup here. Oh, if you can see, there's some shade here, and it's because I'm not lighting the chroma key properly, right? Like now, if anyone made it to the end, the only thing that I can give you, because I'm gonna go now, is that this is the chroma, right? So this part is has its own light, is pretty well lit, so you really don't see anything behind it, right? So if I do this, that's pretty clean, so I actually can show you here, right? So this is the chroma, and this is actually really clean. But if I go to the right and show the chroma, you can see that here there is a lot of black color, so it's not fully green. So there is a lot of dirt there, right? So we need to get another light in here, so we don't see that way. So anyhow, it was awesome to have you. Leave a comment, like, or whatever. Let me know what you think, what you want to see on the live stream next. Bye bye.